Hello students, I am Aishwarya Mohan. Today we are going to start the sessions for digital electronics for the GATE examination. The subject digital electronics is a very important one for the various engineering branches like electronics and communication, electrical and electronics engineering, computer science, instrumentation and applied electronics. For all these branches, the subject contributes about 6 to 10 marks depending upon the branch. So, the entire syllabus of this subject is divided into 6 chapters. That is, chapter 1 deals with Boolean algebra, chapter 2 logic gates, chapter 3 combinational circuit, sequential circuit is discussed in chapter 4, chapter 5 is about logic families, and chapter 6 is about analog to digital converter and digital to analog converters. So, one of the best strategy to crack any competitive exam is to solve the previous year question papers. By completing all the theory papers, solving the previous year questions will improve your confidence level and helps to realize your preparation level. So, it really works and it really helps you to crack the examination. So, moving to the GATE previous year solution for chapter 1, that is the Boolean algebra. So, the first question, the logic function f equal to x and y bar or x bar y the whole complement is same as. So, we can simplify the question itself as this is an expression for x and y bar or x bar and y the whole complement. We know x y bar or x bar y is an expression for exclusive OR. Taking the NOT operation, it becomes exclusive NOR. So, we can directly write the expression as xy or x bar y bar. Okay, so this is our simplified expression given in the question. So, we can look the option A is f equal to x or y and x bar or y bar. So, applying the distributive law, it becomes x bar or xy bar or yx bar or y bar. X bar equal to 0 and y bar equal to 0. Okay. So, the rest is x y bar or y x bar. It doesn't be the option, so it's not. Now, option B equal to x bar or y bar and x or y the whole complement. Applying De Morgan's law, it becomes x bar or y bar the whole complement or x or y the whole complement. So, it becomes xy or x bar y bar. So, it is equal to our function. So, the answer is option B. Moving to the next question, the minimal product of sum function described by the K-map given in the figure. We have to find the minimal POS form. So, for grouping, this is a 3-variable K-map and we need the POS form. So, we have to group the zeros. Here the grouping has already done. So, we can directly write the first grouping is A bar and this is C bar. It becomes A bar or C bar. It's given directly by option B again. Okay. Moving to the next problem. The Boolean expression x bar y z bar. We have x bar y z bar or x bar y bar z or x y z bar and x y bar z and finally x y z can be simplified too. We have to simplify this expression. So, we require a 3-variable K-map. Here it's a 3-variable one. So, we have 3-variable K-map and if you tabulate here, it becomes 0 0 1, 0 0 1, and again 1 here, 1, 0 1 0 1, and then finally 1 1 1. Okay, so this is the first grouping will be like this. Let the function be f, and for this grouping it becomes y bar z, and now the second it becomes y z bar, and finally the third group. The grouping can be done in two ways, this grouping and by grouping these two 1. But here it becomes, if we group like this, it becomes x and y, and if you group these two ones, it becomes x z. So we can check what will happen. Y bar z or y z bar or xy, it's there in the option B. So this grouping is done. We can group, but we can group by these two ones, but it is not in the option, so we adopt this one. Now moving to the fourth question. The simplified form of the Boolean expression y equal to a bar bc or d and a bar d or b bar c. Okay, so we have to solve this. Applying distributive law, it becomes a bar bc and a bar d. So again a bar bcd or a bar b and b bar c. There b and b bar becomes 0. So a bar, so this term will be equal to 0. Now third term, a bar d and d, it becomes a bar d or b bar c d. Okay, so from the first two terms we can take a bar d as common. A bar d and becomes bc or 1 or b bar c d. Okay, so here it becomes a bar d or b bar c d, because a or 1 equal to 1. So this term will be equal to 1, and finally we will get a bar d or b bar c d. So it is in option here we have a complement. It becomes a bar d or b bar c bar d. It's in option A. Okay. So moving to the next question. Question number 5. In the given figure, if the input is a sinusoidal signal, the output will appear as shown in. We have 4 options here. So this is our circuit and this is our input. The circuit represents an op-amp. We know the output of an op-amp will be in the saturation level having 180-degree phase shift. So if the input is given, we have 4 options here. If a sinusoidal input is given, during the first half cycle, this diode will conduct and it makes the negative terminal on, and the output appears as negative saturation, which means the output of an op-amp will be in saturation value, so the output becomes negative saturation. And during the next half cycle, this diode is reversed and becomes forward, and then the output will become positive saturation. Okay, so the option will be option C. Now moving to the next question. The following Carnot map represents the function f. We have given a Carnot map. We have to simplify this. So first of all, here we have 2 grouping. So it becomes our f equal to, here by this grouping it becomes x bar y bar, and here we have x, and here we have yz. Okay, and the next grouping is like this, so it becomes yz. So the expression leads to option B, f equal to x bar, y bar or yz. Moving to the next question, which of the following circuit is a realization of the above function f? Which means the question is from 6. Here f equal to x bar, y bar or yz. We have to find the realization using the logic circuit. So here we want two NOT gates to implement x bar, y bar, right? So simply we can adopt option D, because here we record two NAND gates and here it becomes x bar and here it becomes y bar, and here it is x bar, y bar, and here it is x, y, z, and here it becomes y. So here it is x bar, y bar or y, z. In all these three options, we have only one NOT gate, so we are not able to take the complement of both the input x and y. So we can directly write the option D as the correct answer. Now moving to the next question. Question number 8. In the sum of product function f of x, y, z equal to sigma 2, 3, 4, 5. The prime implicants are. We have to find the prime implicants of this function. So we have to solve it using the K-map. Before that, what is the prime implicant? Implicant in a K-map means we have done the grouping of ones in the K-map. The number of groups in a K-map is known as the implicant, and the highest possible number of ones present in the group. If there are the grouping of 1 consisting of 2 ones and 8 ones, then the prime implicance is that 8 ones, that's the number. So here to solve this, we want a 3 variable K-map. So it appears like this. So for 2, 3, 4, 5, 2 and 3, then again 4 and 5. So we have 2 groups of 1 and we have 2 prime implicants, right? So if we solve this, function f will be, here the first group is x bar, y or x, y bar, becomes x bar, y or x, y bar. So it is in option A. So moving to the next question. Which of the following is an invalid state in 8421 binary coded decimal counter? So for BCD, that is a binary coded decimal, the valid states are from 0 to 9. So a number greater than 9 will be an invalid state in here. So here it is equal to 8, 1, 0, 0, 0. Here it is equal to 9, it's also valid. Here A is also valid one. And for 0, 0, 1, 1, it is equal to 3, it's also a valid state. But here option D, 1, 1, 0, 0, which is equal to 12 in decimal, it's not a valid BCD. So our option is D, which is equal to 12. So we are moving to the next question. Question number 10. The SOP form of a SOP, that is the sum of product form of a Boolean function is sigma 0, 1, 3, 7, 1, 11, where inputs are A, B, C, D, where A is the MSB and B is the LSB. The equivalent minimized expression of the function is, we want, in the question SOP form is given, but in the answer, if we look, we can understand that the answer is obtained in product of sum form. So using this SOP expression, we have to find the product of sum expression. So this is a 4 variable K-map. So we require a 4 variable K-map. Then if we group or if we tabulate all the zeros, because we want to find the product of some form. So the first group of zeros will be this, and for this it becomes, here we have the MSB as A and LSB as D. So for the first grouping, our F becomes C, C bar or D. This is our first group. And now the second grouping will be like this. It becomes A bar or B. A bar or B bar. And the third grouping is this one. It becomes A bar or C. Becomes A bar or C. And finally this group, that is B bar or C. So this is our SOP. From SOP form we have find out the product of some form for this K map, and here the option is similar to option A, that is B bar or C, A bar or C, A bar or B bar, C bar or D. So this is the POS form for this expression. Now moving to the next question. F of A, B, C, D equal to pi of the max terms 0, 1, 3, 4, 5, 7, 9, 11, 12, 13, 14, 15 is a max term representation of the Boolean function f of A, B, C, D, where A is the MSB and D is the LSB. The equivalent minimized representation of this function is. So we have to find out the minimized representation of this Boolean function. But here we have, in the question we have given the max term representation. But in the options, in the answers from A, B, C, D, we have both POS and the SOP form. So we don't know how to find this. First of all, we can solve this for finding the POS form, because we have given the max term representation. As it is a 4 variable one, we want a 4 variable K map. So if we fill according to this max term representation, it comes like 0, 0, 0. Here it becomes 0, 0, 0, 0, 0, 1. Okay, so this is how it looks. And now we are going to group this. This is our first group. So here the function is F. We are going to write the POS form. So we have to take the complement and the OR operation. So here it is D bar. Becomes D bar. And a second group is this. Right? Second group is AB here. It is in the SOP form. So in the POS form it becomes A bar or B bar. A bar or B bar. Right? Now the third group, these two zeros. According to, so this, there comes the 4 groups of zeros. So here it is A, or here it becomes C. So the minimal POS representation is D bar and A bar or B bar and A or C. So this minimal POS representation is not present in our option. So we will move to find the SOP, minimal SOP representation. It's very easy, as we have done the minimal POS form. Just fill the rest of the columns. Okay. Now grouping. This is our first group. F equal to, here it becomes A bar, and here it is C D bar. A bar, C D bar, or these two ones. It becomes A B bar and by this group it becomes A, B bar, D bar. Okay, so this is our minimal SOP representation. Both these SOP and POS in the minimal form is not present in our option. We have the 4 options, it's not present here. What's next? Now we have to check whether a rearrangement in any of these given option will reach or will give the minimal SOP or the POS form. So in the minimal SOP form we have A bar, C, D bar, right? So here in the third option we have this term A bar, C, D bar, right? And we have 2 other terms. We can check whether it reaches here or not. Option C is A bar, C, D bar, or A B bar, C, D bar, or A, B bar, C bar, D bar, C bar, D bar, right? So if we simplify this, keeping the first term as such, A bar, C, D bar, or here from these 2 terms we have A, B bar, D bar, right? A, B bar, D bar, and C or C bar. Okay, C or C bar equal to 1. So the final answer will be A bar, C, D bar, or A, B bar, D bar. So it is similar to our minimal SOP form. So the correct answer is option C. The minimal SOP form is given by the simplification of option C. So this is the minimal representation of the Boolean expression shown in the question. Moving to the next question, question number 12. Consider the following sum of product expression F. So here, this is a 3 variable K map, 3 variable expression. So we require a 3 variable K map, right? And if we fill this according to the sum of product expression given in this question, then it comes like 1, 1, 1. Okay, so this is the SOP representation of this function if it is A, B, C. We have to find the equivalent POS expression, that is the product of sum expression. Here in this option, it is not the minimal one, we have to find the standard POS form, because in the option we have 3 terms, 3 variables here, and each of these terms consists of all the variables either in the standard or in the complemented form. So there is no need to group anything. So we can directly write it as F equal to this cell. The maximum representation of this cell is A bar or BC, B or C, and this cell is A or B bar or C, and this cell is A bar or B bar or C. Okay, so this is equivalent POS expression. Here it is A or B bar or C, A bar or B bar or C, A bar, B or C. So the correct answer is option A. Now moving to the next question. The output expression of the Kondo map shown below. We have to find the output expression of the Kondo map. Here we have both the zeros and 1. First of all, we can group our ones. This is our first group. It becomes A, it becomes C bar. And the other group is this group of 1. It becomes A, right? So the minimal SOP will becomes A or C bar. It's directly in the option, so option B. Moving to the next question. The Boolean expression A or B bar, you can write this F equal to A or B bar or C or D bar or B or C bar, the whole complement. So we can apply De Morgan's law here. We know De Morgan's law is A or B the whole complement. A or B the whole complement equal to A complement and B complement, right? So for this it becomes A or B bar or C or D bar, the whole complement, and B or C bar, the whole complement. Again applying De Morgan's law, it becomes A complement and B complement, the whole complement becomes B itself, and C complement and D, and B or C complement becomes B complement and C, right? Here we have B and B complement, C and C complement. B and B complement is 0, so the ender term becomes 0. So the answer is option D, 0. Okay, so that's all about the previous year GATE questions related to chapter 1 Boolean algebra.